Hello world, my name is Alberto Salgado. It's Engineering 1331, Project 1, Conversion to Solar Energy, Go Green Initiative with Rama Sharaf, Destiny Herrera, and of course me. And the date currently is October 16, 2016. So, to begin, we are provided with the following information, this data of each country in the world, and relative to each country, it is divided into their class depending on their energy consumption. So, for example, in Algeria, right here where I'm circling, if they use between 4.5 to 5 kilowatts hours per meter square per day, then they would fall under that certain class. And this repeats for every country, and they are all divided into their own relative class. But not all classes vary. Not all the countries vary. Some may have more than others, and some may have just less than others. It all really depends. And right here we have a following, just the energy consumption in different units, essentially the same number, just in a different unit. And there's just some information that we have here to better assist us with that energy consumption. And we go over here to our MATLAB program. Just a couple notes before we actually begin, that we actually have some test cases at the end of the script to better assist the user to know what they're working with and better understand how the program works. And here is our problem statement. Energy consumption of each country is recorded and split into their own class. We're developing a MATLAB program that displays energy consumption EC of each country with respect to their class. We compare and contrast those classes based on their energy consumption. Plotting the data into a graph, split the country's data with respect to their energy needs based on megawatt hours per year, gigawatt hours per year, and terawatt hours per year. The countries will display an energy consumption less than average consumption are capable of transitioning from fossil fuels to solar energy. If the energy consumption is greater than the average consumption of solar energy, an error message will display that the country is unfit for transition. Based on any country's energy consumption, we will be able to deduce whether or not the given country is capable of transitioning from fossil to solar energy and to determine which class it falls under. And we have our basic housekeeping commands here. CLC, clear and close, especially since we're using plots at some point in this script. And to begin, we have to bring in our data from the Excel file, and what we use is Excel read, and we have it with this file name, and we're labeling it with the variable data. And we have two informations that we have to get out from the Excel file, which is going to be the first column and the third column, which is going to be our X and our Y axis that we will use later. We're splitting that data, and right here we're defining those variables, and we combine Zin and Yin, our X and Y that we brought from our Excel file, and it's going to be under the variable C, and it's going to be a 995 by 2 matrix. We're sorting those rows with D into sort rows from variable C. And following right here, what we have is the Y minimum, which is going to be the lowest megawatts hours per year, the Y maximum, the highest megawatts hours per year, X and the minimum, which is the lowest class, and the X maximum, which is the highest class. Following here, we extract the dependent values with respect to their class. We're inputting those variables. For example, C1 is class 1, and we do this relatively to every class. So for example, extracting each individual class and storing it in available. So anything with a 1 in column 1 is going to be stored in its own little area. What we do here in this next little area is we take those classes with a 1, and we're storing them with respect to the classes. For example, if any row with the class of 1 is saved with the pair, is only going to pair 1. Classes are sorted from 1 through 10, first column in vector, but their dependent second column vector are not in order in related. They're only related by class number. So this is essentially our new class, and I will type in how that looks. So right here, let me just find it for you. See right here, all the columns, anything with a 1 stays together, and we repeat this for all the classes. And down here we move down to our energy consumption in megawatts hours per year, and we're extracting that from the second column in matrices that we created earlier. We save that into the variable E1, and what we do with E1, we essentially just find the minimum, which is going to be the average megawatts hours per year, and then we also find the minimum and the maximum, which we'll use later. What we do down here, we find the minimum and the maximum for each class. So for minimum of G1, which is our which we saved later and that I showed up here, that looks like this. What we're going to do is going to save that. We're going to try to find the index that's going to be related to that. So in G1, whatever number that's here, we want the second number here, which is here. And we're going to save that in its own variable. And that's going to give us our y minimum and y maximum for each one, for each class, which we'll use later to determine in which class energy consumption lies when the user is prompted to input energy consumption. Right here, this is where the area we ask the user to input energy consumption to classify it to see in which class it lies, and we put that under the variable EC, and from right here we try to set the limits to the given energy consumption in order to determine in which class it lies. And we have a couple else if commands that we use here, and right here, for example, we have energy consumption if it's greater than y minimum and less than the maximum or class of 1, to make it easier for you. It's going to fall between in class 1, so the energy consumption is in class 1, and we repeat this for the following, for all the way 1 through 10. And we have a couple error messages here just in case you put a negative number, then it's below minimum demand. If you put a number that's higher than the maximum, it's above maximum demand, and the program will automatically shut down and stop there. Right here we have a couple energy consumptions. We began with megawatts hours per year, and we went to the following one that we go to. It's gigawatt hours per year, and then we go to terawatts. And I just have the following conversions right there, and it will display these once we actually have the energy consumption, and we'll be able to make that conversion in the command window. And from right here we determine if the energy consumption is within range to convert to solar energy. This is where that mean comes in, and if it's greater than, it's not suit, or it's unfit in order to convert to solar energy. But if it falls between the y minimum and the mean, it will not work. And right here we plot the following. We plot all the classes and relative to whatever information they came with. We plot them into a graph, and we do this for every class, giving them their own colors, their own fills, and we add their following elements. Right here we have classes, megawatts hours per year for the X and Y label, grid, adjusting the axis, the title, and the legend. And in this area, this is where we have the test cases that the user can input. And this is essentially how the program runs. A good little test case here that I will run really quick. It's going to be right here. And that's what we'll get. So you input that number, it gives us that that this energy consumption falls between class 7, and this gives the information of how all the classes look and how they vary into a nice little graph. And that's how it works. And if you input negative numbers or a positive number that's greater than, like, it prompts you those error messages that we talked about earlier. But essentially this is the program, and if you have any comments, make sure to let us know what we could improve, and that'll be great. Thank you very much. This is Alberto Salgado. Thank you.